Hi, everybody. Good morning, good evening, good afternoon from wherever you're tuning in. I know it's been some time since I last recorded the video, but all this while I was not well. Um, but the idea is that I'll consistently be uploading videos from now on. Uh, in today's video, we will be focusing on the retrieval augmented generation or the RAG part of Langchain. What we'll do is we will see how a question and answering system is formed. We will also see how we create a chatbot which indulges with us in a conversational format. So it's going to be divided into two parts. First part, we'll see how we create a question answering system wherein you simply ask a question to the system and it returns the answer to you. And in the second part, we will see how do we convert the entire system into a conversational mode wherein the chatbot also has context, is aware about the context, and he would know about questions that you have asked earlier also. So it will have some its own in memory as well. So we'll see that in this video. I want to draw your attention to this particular blog that I've written. It's been some time. I wrote it back in the month of June, but it's still relevant. So and the theme of this is RAG updated question and answer and conversational. The reason I've mentioned RAG updated here is because earlier Langchain used something called as conversational retrieval chain and retrieval QA. So retrieval QA was used for question and answering, and conversational retrieval chain was used for um, chatbot or the conversational perspective, right? So we used to use these two combinations to do the question and answering as well as the conversational part and create a chatbot. But what is happening is Langchain in its newer version is slowly deprecating both conversational retrieval chain as well as retrieval QA. And what they're replacing these two things is so retrieval QA is now getting deprecated and it will be replaced by something called as create retrieval chain, and conversational retrieval chain is now deprecated and will be replaced by something called as create history aware retriever chain, right? So what happens is when you need to create just a question answering system, your conversational retrieval chain will work. But when you want to create a chatbot, then you'll have to use create history aware retriever in conjunction with create retrieval chain, and something that we'll see in the video as well. So for the purpose of this example, what I am going to do is I'm going to use this particular PDF, which is short stories for children, and it has two very famous stories that I'm sure all of us have gone through. One is Little Red Riding Hood, and then the other one is Snow White and Seven Dwarfs, right? Because it's a PDF, so what we're going to do is we're going to use the PDF loader file, and as you can see in the extension, it's already coming out. So let me go ahead and accept this code. So from langchain dot document loaders import py-pdf loader, and then loader is equal to py-pdf, and it takes the let me take the path, copy the path from here, and I'll put it here. And then page is equal to loader dot load. All right, there you go. Fantastic. Now before that, I want to tell you that I've done all the pip installations for Langchain, OpenAI, Langchain community. For OpenAI key, you'll have to create your own account on OpenAI. Um, it doesn't take a lot of money. I've uploaded my account, OpenAI account, for $10, and I've literally be using it for eternity now. So, and then you also need to do the pip installation for PyPDF because we will be playing around with the PDF file here, right? So now that you have imported PyPDF loader, and then you have also been able to load your pages in loader, and through that we have been able to load our pages in the pages segment as well. Now the next thing that we need to do is see what's there in the pages. So your pages will have like everything that's there in the document, right? And then if you do pages 0 dot page underscore content, you'll be able to see is um, what's there in the first cell of the pages array. This is what you get, right? Now, if you do pages of 0, you'll see everything. You see the metadata, you'll see the page content, so on and so forth, right? So this is how you do the you load the PDF in your Langchain, right? Now the next thing that you need to do is you need to do text splitting, you need to do chunking, and for that I'm not going to be dwelling deep into it, but what I want to do is I want to come here and then use this particular thing for text splitting. So you have text splitter is equal to recursive text splitter, chunk size is equal to 100, 1000, chunk overlap is 200, and splits is equal to this particular thing. Now for pages, we're going to be using pages here, and now recursive text splitter is something that you get from Langchain underscore text splitters import recursive text splitter. So splits are done, fantastic. Now the next thing that you need to do is once the splits are done, you need to save these splits into some sort of vector. So for our purpose, we will be using fast GPU. Initially, we'll do the pip installation with pip install fast GPU, and along with that, we'll have to also do the pip installation for sentence transformer. Now, instead of sentence transformer, we could have used the OpenAI sentence transformer. It's totally up to you. So I've used this. I've installed both fast GPU as well as sentence transformer. Now the next thing, let me hide this first. Clear selected output. Now the next thing that we need to do is we need to create embeddings. Now in order to create embeddings, which we'll have to use the sentence transformer embeddings, which will come from this particular installation, and then also from langchain.embeddings import sentence transformer embeddings, and we'll give this a model name. This is just a default model name as well. Even if you don't give anything, it will still take this. So now we have the embeddings ready with us. We have the FAS or the vector store also ready with us. Let me clear the selected output as well. Now the next thing that we need to do is all the splits that we have created, and then we have to store that as embeddings inside the database called FAS. Understood? So all the splits that we have created here, we will convert this into embeddings using the sentence transformer embeddings, and then we will put it or store it in a store which is called vector store, and will be stored in the FAS database. Understood? Now let's do something. Go to vector store dot similarity search, and within this, let's say who did Red Riding Hood live with? So little Red Riding Hood used to live with her mother, but we'll see what response we get from here. Now you see what this is going to do is it is going to check for the most relevant section of the split, and it is going to throw the top three answers to us. Okay, so let's say doc of 0. If we do, we'll see what comes out. It's a metadata little red riding hood, uh, and then we'll see what's there in doc 2. We'll get some content as well. Deep into the wood, anything is possible, taking animals. So what this is trying to do is the question that we have asked, it is going to go in the FAST database, and it is going to come up or retrieve top three, top two sections of that particular vector store. So this is how this works. Now the next thing that we need to do is we need to create a context aware LLM chain, and for that we'll use something called as create stuff document chain, and I'll show you the documentation for that as well. Create stuff document chain. Now what happens is it specifies how retrieved context is fed into a prompt and LLM, and in this case will stuff. What we'll do is we'll not get into the definition right now. let's get into code, and then I think that way it will be a lot more helpful. Initially, what we'll have to do is we'll have to set up certain building blocks. So for that, we'll we'll create the chat prompt template. We'll create the chat OpenAI LLM as well. So from Langchain underscore core dot prompts import chat prompt template from Langchain underscore OpenAI import chat OpenAI chat OpenAI and and then LLM is equal to chat OpenAI. I don't know why I keep H as capital as this. It happens every time. But anyway, so this is what we have created. Okay, we have created a chat prompt template. We have created a chat OpenAI object as well. Now the next thing that we are going to do is we'll create a template. Template is equal to, and hear me out, follow me for some time, and then I'll tell you why I'm doing all this. Let's create a template which is something like this. Answer the following questions based on the context. We'll set the context here, and then question will come here. Okay, simple prompt, simple template that I've created. Okay, fantastic. We have done great so far. Now let's see how the create stuff document chain object is created. So for that, we'll simply copy the code from here from langchain underscore chains dot combine document import create stuff document chain. Let's go back and create this. And then along with that, so what happens is create stuff document chain takes two arguments, LLM and prompt. So LLM we already have here. But we'll have to create a prompt. So let's go ahead and create a prompt is equal to chat prompt template dot from template, and we will feed the template that we have created here. So now we have the prompt, we have the LLM, and let's go ahead and um, give it to create stuff document chain. You don't have to like specifically give this. There you go, fantastic. So now we have created this. Now let's go to the definition and see what it says. The definition says create stuff document chain specifies how retrieved context is fed into a prompt and LLM. In this case, we'll stuff the content into a prompt. Again, it's a little complicated, so let's take an example. So let's take a example scenario. In our scenario, what we'll do is let's create a context, and we will ask a question on that context as well. Context. So the one second. So the context is the sun rises in the east and sets in the west. And then the question is, where does the sun set? Okay, fantastic. We have the question, we have the context as well. But context, it doesn't go straight away in this way, because we know that it usually goes in the form of a document, right? It goes in the form of a document that has page contents. We'll have to import the document as well. So from Langchain underscore, how do we load the document load in Langchain, document in Langchain, document underscore core, I think this is how, core dot documents import I think it will work. and then we will give document, and within this we'll give page con content is equal to context. Now this is the way we want to give our the context. Now we will give this in the the create document stuff document chain that we have created. So we'll use document chain dot invoke, and we will give context. Maybe we will give document, and input we will give question, and let's print it so that we'll see what result we get. Hopefully this should work. Okay, now this has to be given within parenthesis. That's the way it works. So let's give this as, have I done something wrong here? Input, this parenthesis will come inside, not outside. Yeah, I think it should work now. Tuple attribute has no, okay. This has to come as an array. Now we'll see if it works or not. Fantastic. See, it works. The sun sets in the west. So what we have done is, to the document chain, which is nothing but an object of create stuff document chain, what happens is you pass on the context, which is the sun rises in the east and sets in the west. Okay. And you pass the LLM and the prompt. Okay. Now let's go back to the definition, and now we'll try and superimpose it with the example that we have seen here. Now create stuff document specifies how retrieved context is fed into a prompt. So this is a retrieve context. This is a retrieved context, and now we are feeding this into a prompt, because create stuff document chain already has an LLM and a prompt. So we are feeding this context to a prompt, and in this case we stuff the content into the prompt. That is, we will include all the retrieved context, which in this case is this thing, into a prompt without any summarization or other processing. It largely implements our RAG, and this is exactly what it has done. It has implemented the RAG in a way we have asked it a question and it has given us an answer. The sun sets in the west. Now that we have done the example scenario, the next thing that we are going to use is, we are going to use this document chain in our context. So let's say, let me put the message as well. Now let's use it in our context. So we'll simply do document chain dot invoke, and within parenthesis we'll give the context as splits 0. So you remember we created the splits here, this particular thing, splits. So for our context we'll give this splits of 0 as the context, and input is, oh, that's a good question. So something that we have been using as well. So let's accept this. Who did Red Riding Hood live with? And let's see what answer we get. Okay, splits 0. Tuple object is no attribute page content. So okay, it has to be within this array. Red Riding Hood lived with her mother in the forest. Fantastic. So now you understand what is the usage of create stuff document chain. It will it creates a sandwich of LLM and prompt, and then when you give a context to it, what it will do is it will um, put the prompt and the LLM on top of it, and it will try and find the answer for you. Now this is the underlying of the question and answering system, or the conversational chatbot that we are going to create. I hope things are clear so far. Now that the base is set, next thing that we need to do is we need to create our question answering system and conversational chatbots. Okay. So firstly, we'll build the question answering system. For that, what we'll have to do is we'll have to create something called as create retrieval chain, and I'll go to the documentation as well. Create retrieval chain. It adds the retrieval step and propagates the retrieved context through the chain. Now, the chain that they're talking about is the document chain that we have already created in our last step, document chain. But what is this retriever step that they're talking about? It is nothing but a retriever object that we get from the vector store. Now, let me take you back to the vector store as well and show you what they exactly mean. So, vector store, this is what is vector store is, which is it's a database. It's a fast database that has all the splits converted into embeddings and saved inside a fast database. So this is what the vector store is. And we'll use a retriever is equal to vector store dot as retriever, and then within this we'll use something called as search type as similarity, comma search. So okay, so what this does is um, whatever context we have, it will be put inside the vector store. Using the search type similarity, it will fetch the top two outputs. That is what a retriever store is. Okay, that is what the retriever object is. And in the definition, which is this particular thing, they were talking about the vector store retrieval only. Okay, now let's see how the create retrieval chain is created. From langchain.chains import create retrieval chain. So that's what we're going to do, and then we'll come down and see how it's created. Question answering chain is equal to create, sorry, rag chain is equal to create retrieval chain, passes on the retriever and then the document chain. Fantastic. So question answering chain is equal to create retrieval chain, and we'll pass on the retriever retriever along with the document chain that we have created in the last step. Let's Fantastic. So this is now created. Okay, now what is the next step? After we have created this, we have passed on the retriever, we have passed on the document chain. What do we need to do? We simply need to invoke this chain that we have created by passing on the input. So let's do it. Response is equal to question answering, actually coming out well. Question answering chain dot invoke, and within this, we'll give the input as who did Red Riding Hood live with. Okay, and let's run this. Fantastic. So we have got the response as well. We'll see what comes as part of the response object. There's an input, there's some context, there's some data document that has the metadata, so on and so forth, and finally you have the answer. The Red Riding Hood lived with the mother. So instead of this, let's say we'll do response of answer. There you go. Red Riding Hood lived with her mother. Fantastic. So now what we have done is we have created a question answering system, which is using create retrieval chain. And then the other important thing that it's using is something called as create stuff document chain. Now I hope you have understood the base, which is the create stuff document chain, which uses an LLM and prompt, and the context that we feed to this create stuff document chain, it puts the LLM and prompt on top, and then it gives some answer. But to streamline this, we'll use create retrieval chain in order to create a question answering system, and then we get a straightforward answer to it as well. I hope this clarifies how we create a RAG question answering system, right? What I want you to do is I want you to create a Streamlit application for just this bit as of now, and then next we'll move on to the RAG conversational chatbot. So in this video, as you have seen, what we have done is we have created a base layer of create document stuff chain, and then on top of it we created the question answering system. In the next video, what we'll do is using the same base layer, along with the RAG QA system that we have created in this video. We will then build a conversational chatbot. So stay tuned for the next video.